BILLVEZIERA'S Best Solutions, where we talk about chemistry and mathematics. This is the past paper for 2020, chemistry paper 2, not chemistry paper 2, science paper 2. And we'll go through the selected questions, and those are A18, B1, B3, and B8. So let's start with the A15. Which information given in the table below is true about the industrial preparation of nitric acid? A, B, C, D, and our answer is just B, because also production of ammonia or nitric acid is found on the topic called ammonia, and it's one of the importances of ammonia. Okay, A18. The table below shows boiling point ranges of fractions collected from distillation of a sample of petroleum crude oil. Which fraction contains the smallest molecule? Now, this one again is just a simple thing, because what we have to know is that in hydrocarbons, smaller molecules have weaker intermolecular forces, and this results in a lower boiling point. So we just go to where we have the lowest boiling point. Of course, here we just find the differences, and where we are going to find the lowest boiling point is on A. So A is an answer. From there, let's go to B1. This is B1. Study figure B1.1 and table B1.1 below and answer the question that follow. We have this diagram, and the table is here, and we are asked to identify process A in figure B1.1. Process A is this one. Now let's look at the particles, the arrangement of particles here, here, and here. So here we see that these are closely packed, and this is solid. The arrangement is somehow different to this one. So that is a liquid, and this is gas. So the change from liquid to gas. Oh, sorry, this is for gas, this is for liquid, this is for solid. The difference is that this for solid, the particles are arranged in a certain pattern, in a regular manner, but this one, it is in irregular. So this is for liquid. Okay, let's proceed now. Identify process A in figure B1.1. So this one from solid to gas, and that is sublimation. Sublimation. My pen is too big. Let me change something. Let me change it. Okay. Sublimation. Sublimation from liquid, from solid to gas, that is sublimation. Okay. B, oh, this part, identify two substances that can undergo process A, which is sublimation. So we get them from this table, and it is iodine chloride, it is iodine chloride and iodine crystals, iodine crystals and ammonium chloride. So those are two substances. Now state whether process B and C are endothermic or exothermic. Explain your answer. So let's go to B. B, which is from liquid to gas. So this was gaining kinetic energy. So that is endothermic because heat now was used in the system. Then C, from liquid to solid, it was losing, so it was released to the surrounding. Okay? And the explanation is just very simple, because when losing heat, the particles come together, and when gaining heat, the force that is holding them is broken, and they have kinetic energy. Okay, that's done. Now let's go to B3. In an experiment to prepare a salt, Elena reacted 3.0 grams of magnesium oxide with 40.0 cubic centimeters of dilute nitric acid of concentration 2.0 moles per cubic decimeters. Write a balanced equation for the reaction. So we have magnesium oxide, which is M capital letter G O plus nitric acid, that is HNO, then reacting you get magnesium nitrate, then 2 plus water. Balancing the equation, you just add 2 here, then it's done. Calculate the number of moles of magnesium oxide. Number of moles of magnesium oxide, we know that in the question we have the grams, the mass of magnesium oxide. So just use the mass, just use the formula to say number of moles is equal to the given mass over the molar mass, and this will give us 3.0 over the molar mass of magnesium oxide, that is 40. Okay, then dividing there, we get 0.075 moles of magnesium oxide. Okay, that is done. Then on finding the moles of nitric acid, let's go to the information we have. We have 40 cubic centimeters of dilute nitric acid and also we have its concentration. So here we will use the formula for concentration, and the concentration is found by number of moles over volume. Now let's see the units. Here we have cubic centimeters. On the concentration we have cubic decimeters. So it's us to choose which one are we changing. So let's change the cubic centimeters. And changing cubic centimeters to cubic decimeters, we just divide by 1,000. So here we know concentration is 2. So 2 is equal to number of moles over volume. 40 divided by 1,000, we have 0.04, and doing calculations here we'll have 0.08 moles. Okay, determine the limiting reactant between the magnesium oxide and dilute nitric acid. So first we look at the mole ratio of these reactants. They will reacting in a ratio of 1 to 2. That's to mean we need 2 moles of nitric acid to react with 1 mole of magnesium oxide. Okay, now let's see. So for magnesium oxide it was 0.075, and this we say we need 2 moles of this. We need 2 moles of nitric acid to react with this one. So say 7 or 0.075 to react with for this one. Now let's see, if we multiply this by 2, what are we getting? So we are getting 0.15 moles. So let's check the moles of nitric acid we have. We have 0.08 available. Now comparing it to the required one, we see that the required one is bigger than the available. That's to say, this one will get finished in the process, and nitric acid qualifies to be a limiting reagent. So nitric acid is a limiting reagent. Just like that. Okay, then let's go to B8. B8 reads urea, CON, that one, and ammonium nitrate, that one, are 2 nitrogenous fertilizers commonly used by farmers. Now calculate the percentage composition of nitrogen in urea. So we know that percentage composition of a substance, for example here is nitrogen in urea, that is N2, is equal to the molar mass of it over the molar mass of a compound. In this case, the compound is urea, times 100%. Then the molar mass of nitrogen, that is that is 28 over the molar mass of urea, it is 60 multiplied by 100, and we get 46.666, rounded off to 2 decimal places, it will be just 0.67. Okay. B. Explain the importance of nitrogenous fertilizers in agriculture. Nitrogenous fertilizers in agriculture promote growth. Promote growth. And how does it promote it? It acts as a key component of amino acids, which are building blocks of plant proteins. Now, describe the effects of using nitrogenous fertilizers on the environment. This one, again, it causes eutrophication. It also causes soil acidity if it is used for a long time. So soil acidic. I won't write what I have explained, the space is limited. Okay. Apart from nitrogen, name an element needed for root development. This is phosphorus. Okay. Apart from nitrogen, name an element needed for seed formation. Still phosphorus. That's the end of the questions for today. 077913869792. That is a WhatsApp number.